Alright, so this simulation is going to talk quite a bit about air masses and fronts. We are going to try to get some general information about what air masses look like and how air masses produce the weather that we have. You should have done the self-assessment questions. So with the self-assessment questions, you should have indicated whether you think the statement is true or false, and then specify how confident you feel. So warm air is more dense than cold air. Is that true or false? And then your level of confidence. A cold front is produced when relatively cold, dry air pushes into warmer, more humid air. Is that true or false? And then the final one, clouds are always found near fronts because air is being forced upward. Is that true or false? Our objectives. Our objectives are to define density and explain how differences in temperature affect the density of a fluid. We need to discuss the temperature structure of Earth's troposphere. Remember, the troposphere is the layer of the atmosphere in which we live. We're going to explain how convection is able to move heat through the atmosphere. We'll discuss the formation and destruction of temperature inversions near the ground. We'll define a front and recognize the physical characteristics of cold, warm, and occluded fronts. We'll define air mass and discuss where instability may be found, and then explain the causes of clouds and precipitation. So let's flip to the next page. Here are our discussion questions. What is meant by density of a substance? Think all the way back again. We keep coming back to this word density quite a bit, don't we? What is density? What is density? You could give me the equation, or you could give me just a general definition. Nate?
I think the equation is mass divided by
Density equals mass over volume. Okay.
I think it's volume over mass.
I think it's volume over mass. Ooh, is it mass over volume or volume over mass?
Oh, mass over volume.
Mass over volume. D equals mass over volume. Density equals mass over volume. Yes, sir. Okay, very good. The amount of matter, or the amount of atoms in a given space. So if we're talking about density of substances, we're going to talk about how closely packed those atoms are together. All right? Liquids, or fluids, both gases and liquids, can have differences in density depending upon temperature. Okay? And so this simulation is going to represent something that happens in the atmosphere, but we're going to use water because both of them act just like, or both of them are fluids. They both act in a way where they flow. Okay? Number two, under normal atmospheric pressure and temperature conditions, which of the following are fluid? Underline the appropriate response. Which of these three, we got solid, liquid, gas, which of the three are fluids? Mr. Weeks, do you have one of them as a fluid? Follow along with us. There's three choices. Of those three choices, what is a fluid? Okay, so he says liquid. Is that it?
Yes.
And gas. Very good. Both of those are fluids, so underline both of them. Number three, what is an air mass? What is an air mass? A mass of air. That is true. It is a mass of air. We got to have more than just a mass of air, though. A mass of air that what? Mass of air that what? Miss Wolf. There are warm air masses and cold air masses. Very good. Fronts are related to warm air masses and cold air masses, but they are not the warm air mass and the cold air mass themselves. Yes, sir?
Is that an air mass that flows?
An air mass that blows. No, not necessarily. I mean, temperature differences are going to cause density differences, which are going to cause flow in our atmosphere. So, yes, we can have winds that are associated with air masses, but not necessarily does an air mass really, I guess, blow like wind does. I mean, inside of an air mass, you might have a certain amount of wind. Air mass. An air mass is a mass of air that has a relatively, R-E-L-A-T-I-V-E-L-Y. It's a mass of air that has a relatively similar temperature and moisture content. Mass of air that has relatively similar temperature and moisture content. Yep, content. Number 4, list and describe the 4 basic types of air masses. All right, so air masses, they are categorized based on where they were from, and therefore based on their content of moisture and temperature. So, some air masses form over top of oceans. Some air masses form over top of land. If an air mass forms over top of the ocean, it is called maritime. Maritime. And if an air mass forms over top of the ocean, what do you think it has a lot of it in it?
An ocean. Cold air mass.
A lot of moisture. If it is maritime, it has a lot of moisture. So what is a wet air mass? If an air mass forms over top of land, we call it a continental air mass. It formed over a continent. If an air mass forms over land, compared to a maritime air mass, do you think it has a lot of moisture in it or not? Not. So it is going to be what type of air mass? A dry air mass. Dry air mass. I don't have time for you. I got a different class.
I can see like how it's called like the way to remember it.
Okay. Air masses are either dry or they are wet. Air masses can also be hot or cold depending upon where they are formed. An air mass that forms in polar regions,
Is it polar? Air mass.
is it going to be a warm air mass or a cold air mass?
That'd be a freezing air mass. Probably get bad.
Okay.
Almost go down polar bear.
Are you cold? Oh my god, I remember that. You're welcome. What?
You guys, that is recording and it's picking up everything that you say. An air mass that forms in a tropical region is going to be a warm air mass.
So if it's formed over a tropical region?
Good boy.
Formed in a tropical region is going to be 1. All right. The way in which we identify the 4 different types of air masses is based on the source locations that they come from.
I get it.
Whenever we write a type of air mass, we write it out using symbols. The source location over land or water always comes first. If it is a maritime air mass, we write it with a lowercase m. If it is a maritime air mass that formed in a polar region,
MP.
it's going to be a P. Equals maritime polar. And a maritime polar air mass has what 2 characteristics?
Wet and dry. Or wet and cold.
No, like ice.
Okay.
We were.
Yes, write this down. A maritime tropical air mass is an air mass that formed over the ocean. It was formed in a tropical region, therefore it is warm.
Yeah.
So it is wet
I see where you're going.
and warm. A continental polar air mass is a dry and cold air mass. A continental tropical air mass is a dry, warm air mass. Those are the 4 types of air masses that we have that affect the United States and the rest of the world. There are 6 source regions that we get these types of air masses from. We get air masses from up around the Arctic, up around Alaska, and usually those are wet, cold air masses because they formed usually over the northern Pacific Ocean. We get wet, cold air masses over top of the northern Atlantic that sometimes swing back over along our eastern seaboard. We get warm, wet air masses from the Gulf of Mexico. We get cold, dry air masses from Canada. And we can get a warm, dry air mass off of Mexico and our southwest during the summer months. Yes, sir?
I feel stupid after saying this, but can there be maritime and continental?
There cannot. There cannot be a maritime and continental. You can't get a combination of the 2 because they're opposites.
Does a maritime tropical make hurricanes?
Does maritime tropical make hurricanes? Absolutely, yes. Maritime tropical air masses do make hurricanes. Yep. All right. Excellent question. We need to continue on. Number 5, what is a front? A front is the boundary between 2 air masses. A front is the boundary between 2 air masses. The 4 types of fronts.
Wet, cold, dry, warm.
4 types of fronts are as follows. All right, a stationary front. A stationary front is a front that does not move.
Break the chair.
Stationary front is a front that does not move. A warm front A warm front is a front with warm air coming behind it.
Is there a cool front? Oh, damn.
A cold front is a front that comes in
Cold?
with cold air behind it.
And there's
And the final one is an occluded front.
not even a word. Included.
Oh,
Occluded front.
Is that like X?
no.
See what an occluded front is a little bit?
One that moves.
That's stationary.
All right.
You know the good. What does it?
Discussion questions we're done with. Part number 1, air masses and fronts. Although we will attempt to simulate atmospheric phenomenon in this activity, water will be used so that you can more easily see the movements. Air, just like water, flows in response to its density. Make a labeled diagram of the density flow model set up on the illustration below. Cold is blue, hot is clear. You may wish to use a blue colored pencil. Hot will be on the right, cold will be on the left. There are colored pencils at your tables. An occluded front.
Oh, we can pass it down. You just need blue one. Yeah, look, it's a hot blue.
Mr. Dale, are you super strong?
I am. Not super.
Hot's going to be on the right, cold's going to be on the left.
Hey, what's on the way?
Yeah. We can skip by it.
We have to dump
That's
yours in at the same time. You're going to dump yours in this side. Don't break it. We're going to fill it right up. Ready? Yours is on water. Just dump it right in. Boy, yeah, that's
Can't be a warrior.
Yeah, it's alright.
Jaden, it's like if you don't like that color,
Oh yeah.
more away because it's so long and climate.
Hey, what's up, man?
Mr. Windsor,
They're
trying to tell me that warm air is cold air.
No, they tried to say warm air is cold.
All right, our temperature of the cold water is,
There's no water in that, right?
looks like about
Water's
just above 0 degrees Celsius.
How much is that in Fahrenheit? 32 degrees.
34.
Well, I don't know.
No, it should be 34 because it says a little above.
Our temperature of the warm water is right at about 99 degrees Fahrenheit, or 38 degrees Celsius.
99 degrees Fahrenheit? That's even warmer.
Out of the tap.
Oh.
Okay, everyone should have page number 46 done. You should have written your hypothesis down. Hypothesis 1 in an if-then statement. Predict what visible changes will take place above and below the tape line when the partition is removed between the two different temperature fluids. Defend your prediction. So I'm going to, instead of doing a tape line, I'm going to just draw with the marker. Got some condensation going on here.
Oh yeah.
Okay. And the partition is going to be removed. Are you ready?
Oh wait, I haven't written my hypothesis.
If you're in the back, go ahead and stand up. I'm going to shut the lights off too.
That's enough. We can't see over you guys. Sit the back. Okay, you have to
There we go. Once you've observed, under observation number 1 on page number 47, describe what happened. Was your hypothesis correct? Number 1, explain why the fluids changed positions. What do you think? Why did the fluids change positions? Ms. Grover.
Because it's hot and cold, so they're like.
Okay, one of them is hot and one of them is cold, therefore they have differences in what?
Temperatures.
Differences in temperature causes difference in what?
Heating.
In what?
Heating.
Nope. Nope.
Density.
In density. So differences in temperature cause differences in density. If we have differences in density, then one of them is going to flow underneath the other one, because one's going to be more dense than the other. Okay. Number 2, after the partition was removed, where was the most turbulence between the two different temperatured fluids observed? What is turbulence first? We kind of got to know what turbulence is. Yes, sir.
The different like masses of air, like when you're riding the airplane, you get pretty.
Okay, that's true. So what is it? So when you're riding in an airplane, you get kind of your plane kind of shakes quite a bit. What is that? Yes, sir.
That's like the plane stuttering against something, or like they're both stuttering against each other.
Okay, kind of like that statement. Anybody add a little bit more?
It's like differences in air density.
All right, the area where there's a greater difference in air densities between two different locations.
It's like when the plane's like all the way high up in the air, there's more air pressure up there, so well, I don't know.
Less air pressure the higher you go in the atmosphere.
I don't know.
The higher up you go in the atmosphere, the less air pressure there is. The closer to sea level you are, the greater the air pressure is. I kind of like Mr. Walton's definition back there. Kind of the area where we've got two air masses that have a very large difference in density. Therefore, we get a large amount of wind. Okay, there's a lot of moving and shaking that occurs because wind is kind of rolling, and there's those differences in density are causing the atmosphere to be kind of volatile. Yeah.
So cold air is more dense.
Very good. Cold air is more dense. We can see that right now. We see blue along the bottom, therefore cold air must be more dense. Excellent.
And it's above the line too.
It is.
Yes.
Yes, ma'am. What's your question?
Would okay, so
Gentlemen?
when they're like mixing right now, would the cold air become warmer or would the warm air become cold?
The warm air would be giving off heat energy to the cold air. So the cold air would be becoming warmer.
Okay. So then
And the warm air would become cooler because it's losing heat energy.
so then would eventually would that become like all blue?
Eventually it would completely mix, yes. Good. All right, next question. Number 3. What type of front would have been represented before the partition was removed? So we had the partition right here. We had blue on this side, white on, or clear on this side. What type of front would be representative of that partition still staying there? Were either air mass or were either one of these masses moving?
Stationary.
Stationary front. An air mass that is not going anywhere. Number 4, assume that the floor of the tank is Earth's surface. So assume we are able to stand on the floor of that tank. And the water represents air masses. What type of weather front did you witness advancing across the Earth's surface? So imagine we're standing right over here, right down here at the bottom. What type of front came across and came in contact with you if you were standing down there, Caden? Good. A cold front. The water sunk down, it circled over, and it flowed this way. Okay? Be a cold front. Number 5, assume that the marker line represents the Earth's surface. What type of front would be advancing if this were the case? So if we assume this marker line right across the middle is Earth's surface, and we're standing on Earth's surface right here. What type of front would have moved in, if we were standing, say, right over here, I guess. What type of front would have moved in? Miss Davis. A warm front. The warm air pushed in over, it's been a warm front advancing. Number 6, what happened after the internal waves calmed down, and where is the warmest water and why? What happened after that calmed down? So right now, everything's calm. What happened? Nate?
The blue, which is the cold, some under the warm, because cold air is more dense than warm air.
Yeah. Yeah, so they actually kind of reached a little bit of equilibrium. But as Ms. Wolf mentioned, right now we still got this warm water, or this cold water down here that's gaining heat from the warm water. So if we sit here and we look at the thermometers, we can see where this area right here is probably slowly warming up. And you'll notice down here, eventually this is going to slowly warm up as well. If we were to let this sit here for long periods of time, the water would become the same temperature all the way throughout. air masses do eventually mix. However, it happens very, very, very slowly. And at the same time, air masses are constantly moving through the planet, and they're kind of, you guys have you ever seen one of those lava lamps?
Yeah.
Where the big heated blob kind of comes up, moves around. Our air masses actually work a lot like that, where we have a big section that's heated near the equator, so it kind of blobs up towards the north, and we have areas of very cold air that are found near the polar regions that are going to be very cold, and they kind of blob down towards the equator to be reheated, and that process just continues to occur. Yes, sir?
So that right there is basically like a lake, kind of.
It is. Yeah, that's a good example of that. So, it's summertime, you go swimming. You go out in the Rainbow Lake. You get in the center of the lake, and the surface water is heated by the sun, but the water that's underneath doesn't really get heated very well.
That's what catfish is.
So you are sitting here swimming, and maybe as you're swimming, you're standing kind of up, or you're kind of standing in the water column, I guess is the best way to say that. And your toes feel very, very cold, but your upper body feels real warm. It's because of Earth, or the sun being heated, or heating the water, and we're getting kind of this big difference in temperature right there. This line right here in water is called the thermocline. It's the drastic change in temperature between the surface waters that are heated and the waters that are underneath that are not heated by the sun. Yes, sir?
So is the Earth like a big lava lamp?
The Earth is a lot like a big lava lamp. Yep. The only thing is we really can't see that happening. The only thing we can really do is measure it with thermometers.
What if we had like a thermal camera?
If you had a thermal camera, you'd be able to see that kind of stuff. Yes.
That'd be awesome.
You kind of see where big sections of warm air blob up towards the north, big sections of cold air blob down towards the equator.
They should put a big.
Yes, sir.
But wouldn't it change temperature if it was shallow water?
Yes, it would. You wouldn't see this difference in temperature in shallow water because you have a large amount of sun rays going all the way through the column. Only in deep water does this occur because in the deep water, sunlight can't penetrate all the way through the deepest part of the lake. Yes, sir.
If they did like a thermal camera on like a satellite or something, would you be able to see the fish in the ocean?
Would you be able to see the fish in the ocean?
I
I don't know. I don't know. They would be, fish have temperature that's the same as their surroundings. They're cold-blooded. So I'd say probably not, because really all you'd see is the temperature of the water, and their body temperature would be the same as the temperature of the water. So yeah, they're not real warm compared
so if they
to
swim in
other
nitrogen,
things.
they'd be like their body.
Be the same. Yep. All right. Homework for tonight, you guys. How much time do we have left? We got about 6 minutes left. I would like for you to do the extension questions 1, 2, and 3 on the next page. You should be able to finish those in the next few minutes. Okay?